If organisms have to reproduce, then in previous videos we've seen that the cells need to be able to make a copy of themselves, which means that the DNA of a cell must be able to make a copy of itself. Now, if you're not familiar with this, we've talked a lot about this in great detail in a previous video called Reproduction in DNA. But the important thing to note here is that a DNA copy is never 100% perfect. So the way I've shown over here is, as an example, I have changed the color of this line from green to purple, just to show you that it's not 100% perfect. So in this video, we're gonna try and explore a little bit as to why this is not 100% perfect, and then we will see what is the consequence of this. What does it mean for reproduction? That's what we're gonna explore in this video. So let's start with the why part. Why does this happen? Why can't the DNA make a perfect copy of itself? Well, the answer is actually quite simple. It's errors in copying. These are what we are seeing over here are basically errors in copying. And to give you a little bit more, you see, in order for DNA to copy itself, DNA first of all is a very long molecule, and if you want to make a copy of itself, then there are tons of biochemical reactions that need to take place, right? And the thing is, chemical reactions are not always 100% perfect. So something or the other might go wrong somewhere. And because simply errors are definitely possible in our world, chemical reactions are not always perfect. Because of that, and there are so many chemical reactions are happening for DNA copying, put all of them together and you will find that the copies will not be 100% perfect. It's kind of like your friend is trying to copy the recipe to cook pasta. Now, he or she may be writing everything word to word or trying to write everything word to word in her own book, but occasionally she might make some mistakes. She might skip some words, or she might skip some sentences, not purposely, but maybe she would do that. And as a result, if you look at the copy that your friend has made, well, it's pretty much still the same recipe. It is still going to cook you pasta itself, but there might be some changes happening in that recipe. So now this brings us to the question, what happens because of this? What is the consequence of this DNA error in copying? Well, to talk about that, let's get rid of these pictures. And now let's think about what are the consequences. Well, if you look at short term, maybe there are no consequences. For example, when your friend is copying the recipe of that pasta, maybe she misses some of the words, maybe she copies some words wrong, but still maybe the recipe is still exactly the same. The ingredients used are still exactly the same, and so the pasta that she will cook will pretty much be the same as the pasta that you will cook. So remember, your DNA is a recipe to cook not pasta, but to cook proteins. Not to cook, but to make proteins, to synthesize proteins. And so even with small errors here and there, maybe the proteins made by this new copy of the DNA would be the same as the proteins made by the old DNA. And so in that case, your offsprings will look pretty much identical to your original cell. Things may not change. However, as you keep making more and more copies, as you keep making more and more errors, there could be some critical errors that you might make. For example, maybe one of your friends or cousins, people who love cooking around you, maybe one of them, when they're making a copy of this book, maybe they make a mistake in the amount of milk to be added. Maybe originally the amount of milk to be added was, I don't know, maybe 9 liters, but that person makes it by mistake 8 liters. Ooh, now that person's pasta is going to change a little bit. It's gonna taste maybe a little bit different compared to the original one. So you see that pasta will have some changes compared to the original one, and so we say there will be some variations. Similarly, when organisms reproduce, because of the errors that are happening in the DNA, sometimes the error can be critical, and because of that, the proteins built could be different altogether, and as a result, that individual could have some variations. So the consequence of these errors in the copying of DNA is it leads to variations in some organisms. And so I guess now the million-dollar question is, are these variations good or bad? Well, it depends upon how you look at it. In short, here's the thing. If you look at it from an individual point of view, for individual organisms, individuals, we will say, variations can be good, we'll take examples, or it can be bad, Both are possible, or maybe it will be harmless. Like we said before, sometimes it can be harmless as well. So for individuals, it could be good, bad, or it could be harmless. But for the species, if you're looking for the species as a whole, variations are definitely good. In fact, I'll go ahead and say that if you want a species to survive over a long period of time, maybe millions of years, you need to have variations. Variations is the key for the species to survive. Now, why am I saying that? Well, let me take an example to make this clear. Consider a species of bacteria living in water at 27 degrees Celsius. Let's say that these bacteria have adapted for that particular temperature. This temperature is perfect for these bacteria. Then we will say that this particular water at this particular temperature has become the niche for the bacteria. Think of niche as a well-defined space, this water at 27 degrees Celsius, for which the organisms are perfectly adapted for. Okay? Just to give you a more relatable example, think of cactus. The cactus also live in a very well-defined place where temperatures are pretty high during the daytime, no water for a long time, basically a desert. And the cactus has developed or has adapted for that particular condition. So we can say the desert forms the niche for this cactus. Okay? So basically think of niche as a well-defined space for which that particular organism has adapted itself. All right? Now, of course, it turns out niche is a very broad concept. We'll not look at it in great detail. Just think of it as a well-defined space for now. All right? So what will happen? Well, these bacteria will thrive in this particular environment. And so they will reproduce more and increase its population, and they will occupy that niche, we will say. But now let's think about the variations. Every bacterium will have some or the other variations because of the errors in the DNA copying. Some of these variations might be good, or some of these variations might be harmless for this particular niche. So these bacteria will just keep on living and keep on reproducing. They will not be affected by these variations. But what if there are some variations which are bad for the bacterium? Let's say one of this particular bacterium has a variation, this one has a variation, because of which it can live only in higher temperatures, not 27 degrees Celsius, but it is adapted for higher temperatures, let's say. Then what will happen? Well, because it is not perfectly adapted for this particular niche, it might die. Or maybe because it is not very well suited, we might find that it may not reproduce much. Whatever it is, you can see this bacterium is at a disadvantage. And so that's the reason why I said for individuals, variations can be good or they can be bad, because these variations are happening randomly, right? So it can be good or it can be bad. But let's think from the species point of view. Why is it good for species? Well, there are a couple of reasons. One is, you see, for the individuals which have good variations, that's great for the species. They will be able to reproduce and grow in number. Great for the species. But if you consider the individuals that have bad variations, maybe they will die, or maybe they won't reproduce much, and that's fine. That's fine because their numbers will reduce, but there are other ones which are thriving. So the ones that fit in this particular environment will keep on reproducing more and more. So you see, the species as a whole is not affected by bad variations, right? So bad variations do not affect the species. Okay, that's one reason. The second most important reason, though, of why variations are important is because niches can change. And that's important. This can change. So just to give an example, what I mean over here is the temperature of the water will not always remain 27 degrees Celsius forever. Maybe as time passes by, after a few thousands of years, we find the temperature of water is rising. It's rising because of global warming, let's say. Now, as the temperature is rising, now what happens? Now we will see that these bacteria are at a disadvantage because they're adapted for 27 degrees Celsius. But this particular variation now has an advantage, right? Because that is adapted for higher temperatures. And so what will happen now? Well, now as time passes by, we will see the numbers of these guys will start decreasing, but the numbers of these ones will start increasing because they are better adapted to that new higher temperature environment. And as a result, we'll now find this will increase in number. And so you see what has happened? The species has adapted to that change in niche. And so variations allow or prepare the species to adapt itself in case the niche changes. And that's the reason why variations are super, super important for a species to survive. In fact, guess what? Without variations, good chance that you and I wouldn't even exist. Because think about it, the Earth has gone through so many changes. There was a time where the entire Earth was covered with ice. We call that as Ice Age. Then there was a time when Earth got hit by the meteor. So many drastic changes have happened. So many changes in the niche has happened. Then the only way life could survive was due to random variations. Random variations gives the species a chance to survive. All right. So to summarize, what did we learn in this video? We learned whenever organisms reproduce, their DNA makes a copy, but there can be errors in these copies. And as a result, the offsprings will have some variations. If you look at individuals, variations can be good or they can be bad. Some variations might have a disadvantage in that particular niche. But for the species as a whole, the variation is good because niches can change. And just to recall, what's a niche? You can think of niche as a well-defined space for which the organisms have adapted themselves.